look at problem 8. Two stars alpha and beta with the mass ratio of 10 are in circular orbits around each other. In the rest frame of the system, find the ratio of the speed. And the solution simply say, since the total momentum is 0, the ratio of the speed is the reverse of the ratio of mass, which is 1/10. This is, of course, correct, but perhaps a little too brief. Perhaps you feel more comfortable doing some dynamic analysis, balance of force, etc., and derive the result from that. So let's look at it that way. First off, what is the rest frame of the system? They really didn't have to mention it. It's basically defined when you are making the statement that the two stars are moving around each other in a circular orbit. That observation, it must have been made from a certain reference system, and that's basically what the rest frame of system is. As far as this problem is concerned, you really don't have to mention that at all, right? You can just remove that statement and just go straight to asking the ratio of the speed, right? So, excuse me, this motion is centered around the center of mass. That's the center of the circular motions, right? And this is a point sitting along the line connecting the two stars, and the ratio of the radius should be the inverse of the ratio of the mass by definition, right? But you don't really need to use all of that information when solving this problem. You can simply ask yourself about the centrifugal force. The centrifugal force of the two stars must be the same because they both equal to the gravitational force between the two, right? From that triangulation, you know that if you compute the centrifugal force of beta versus alpha, since they both equal to the gravity, they must be the same. And you may recall that the centrifugal force you can choose different expressions. You can say mv squared over r. You can say m omega squared times r. You can say m v omega. We'll choose mv omega because that's the most convenient mathematically. If you simply write down that the centrifugal force are the same for alpha and beta, you have this expression. Notably, omega is the same, right? Because the two stars, they rotate at the same period. So the angular speed, omega, must be the same. And you can readily see from this expression that the two omega cancels each other, and you're left with the same balance of momentum equation that the solution has. And the conclusion follows that. The ratio of the speed must be 1/10.